Welcome to Cloud Genius. Ready to explore cloud tech with us? Welcome to the fourth part of our Amazon EBS series at Cloud Genius. In this video, we are diving into how Amazon EBS snapshots work. We will learn also about the snapshots archive tier and the recycle bin feature that's available for snapshots. So let's get started. So what are the Amazon EBS snapshots that we have referred to several times before? The snapshot is a capture of the data written on this volume at a certain point in time. It's taken to enable data protection and allow for data recovery. You can take for the same volume multiple snapshots at multiple points in time in order to have multiple recovery points. Every time you capture a new snapshot, it doesn't need to copy all of the volume contents. No. EBS snapshots are actually incremental, and only the deltas, these modified blocks from the last snapshot, will be only copied to the new snapshots. These snapshots are stored in an S3 bucket available in the same region of the availability zone of the EBS volume itself. The snapshot is stored reliably across multiple copies, across multiple availability zones, allowing for scenarios of recovery in the case of the whole AZ failure. The snapshot objects are actually containing all of the necessary information needed to help for a data recovery to recover a volume to a functional state. You could take snapshots manually, you can configure for them certain schedule, and you can streamline and automate the whole process via Amazon Data Lifecycle Manager, and we'll explain that in much more detail in the next and the final video. In case you are not familiar with the concept of incremental snapshots, this example might make the concept more clear to you. Let's suppose that you got an EBS volume of 1 terabyte in size, and currently it has no data written to it. You decided to take a snapshot. So you decided to take a snapshot, and currently we will capture the current state of the disk, which is empty. Snap1 is created and its size is also 0. But time passes on and you start writing data to the disk. You have now blocks 1, 2, and 3. And you would decided to preserve and protect the current content of that volume. So you decide to take another snapshot, and in that case you create snap2, and this will serve as a new recovery point. And as you can see, the deltas, blocks 1, 2, and 3 are copied, and this what will be contributing to the size of the snapshot. Time passes, and new data blocks has been written. We have now blocks 4, 5, and 6. And you would like also to capture that new disk state. You would like to have a new recovery point. So what will you do? We will decide to take a new snapshot. And when I take a new snapshot, snap3 will be created. And now we have blocks 1, 2, 3, 4, 5, and 6. But because blocks 1, 2, and 3 were already protected by a previous snapshot, no need to copy them again. And only the deltas 4, 5, and 6, this will be the blocks that would contribute towards the size of my new snapshot. And the story continues in the same way for the new data and for the new snapshots. Remember, please, the snapshot's main purpose is to help you restore your data in worst case scenarios and disasters. You can very simply have tens or hundreds of snapshots that you might need to keep for the sake of compliance. But in reality, many of these snapshots would be rarely accessed. So in order to help keep these snapshots and at the same time control the storage cost, there is a very nice feature known as the EBS Snapshots archive tier. This offers low storage cost for long-term retention of these rarely accessed snapshots. However, snapshots that you move them to that tier has a 90 days minimum retention period. So archive the snapshots that you plan to store for 90 days or longer, and that you rarely need to access. When you archive a snapshot, the incremental snapshot is going to be converted into a full snapshot, and it's going to be moved from the standard tier to the Amazon EBS snapshot archive tier. Full snapshots include all of the blocks that were written to the volume at the time when that snapshot was created. Before using that snapshots, use it to recover back a volume, you have first to retrieve the snapshot from the archive tier back to the standard tier. The retrieval, and you can configure this, could be temporary. This means a copy will be created in the standard tier beside the original snapshot that will be still kept in the archive tier, or you can make the retrieval permanent. You are moving the snapshot back from the archive tier to the standard tier. But remember, retrieval takes considerable amount of time. It can take up to 72 hours to restore an archived snapshot from the archive tier to the standard tier, depending on the size of that snapshot. This is a great feature. It can offer you up to 75% lower snapshot storage cost. This is something that's definitely worth consideration. So if you wondered how does this feature work, it's simply based on simple APIs for archiving and for restoring back these snapshots. The archive snapshot API creates a full version of the snapshot and move it into the archive tier from the standard tier. While the restore snapshot API will do the opposite and to restore a full version of the snapshot either temporary or permanently, as we have previously explained in the previous slide. If you would like to read more about this feature, make sure to check the following URL from the AWS documentation website. The link for that URL will be available in the description below. Now let's talk about one more last feature that could be very helpful. Due to human errors, some incidents might result in accidental snapshot deletion. I would like to protect my snapshots against such scenarios. Here comes the importance of the recycle bin for EBS snapshots. This capability allows you to automatically retain deleted snapshot for a certain retention period that you would specify. Through retention rules of the recycle bin, you would be able to control the duration of that retention period. So when someone deletes your snapshot, let's say by mistake, it goes to the recycle bin instead. And you would have now the ability to recover it back from the recycle bin before that retention period expires. The great thing, there is no extra cost for that feature. You just pay the regular storage cost for your snapshot. And definitely, with the help of IAM policies and rules, you would be able to control who is authorized to edit such retention rules in order to prevent any kind of unauthorized persons from messing up with your policies. Great feature, right? With that being said, we were able to cover the EBS snapshots topic and some of its advanced features. However, we will see in the next and the final video of that series how can we streamline the process of those snapshots creation. Thank you.